All right, so welcome to today's class. We'll be looking at inequalities of all types. Okay, so all the types of inequalities that we have, we're going to discuss them in this video today. Okay, so if you have any questions, please guys, feel free to ask. Okay, um, you have to know these things. So if you don't ask and you haven't understood, then you're just deceiving yourself. So if you have any question, okay, please, just ask, and then I'll maybe explain it in a different way so that you get to understand how to do it. Okay, so the first question can be, what are inequalities? Okay, so I'll start with the equal sign and then I'll go to the inequalities. Okay, so when I say A is equals to B, what does this mean? Okay, when I say A is equals to B, then it just simply means that, okay, A and B are the same. Okay, that's what the equal sign means there. It means A and B are the same. No wonder we're saying A is equals to B. Okay, so now when we come to the inequalities, okay, we have four of them. We have the less than, okay, we have the less than or equal to, then we have the greater than, and then we have the greater than or equal to. So what are these things? Okay, so inequalities, these are just used, okay, to check the relative sides of the magnitude of what you have on the left and what you have on the right. So for example, if I write, okay, if I write that A is less than B, this simply means that this A here is smaller in magnitude, okay, than this B here, which is what? Which is bigger. Okay, so the inequalities, they simply show the relative sides of the left and the right side of whatever equation that you have. Okay, yeah. All right, so if again I write maybe B is greater than or equal to A, this simply that this B, okay, it can be the same as A, okay, it can be the same as A or any number that is what? Bigger than A. That's what this greater than or equal to means. Okay, so the inequalities, they'll just be telling the relative sides of what you have on the left and what you have on the right. So they will show you, in short, they will show you what is bigger. Okay, is it the left hand side which is bigger? Is it the right hand side which is bigger? That's what they will do. Okay, so now when we come to the inequalities, okay, we have a lot of types, okay, and we are going to discuss all of them in this video. Okay, so the inequalities are divided into categories. Okay, so I think the categories are about, is it 5 or 4? Okay, we'll see. So the first category of these inequalities is what we call as the linear ones. Okay, so linear inequalities. So this is the first type of the inequalities that we have. So for example of this is simply, okay, an example of this is simply, if for example I write 3x, okay, maybe plus 5 is less than 7. Okay, so this is a linear type here. Why? Because the highest power on the variable x, which is this guy, is just 1. So this is a linear inequality. Okay, it has the inequality symbol and then it is linear. So we call it a linear inequality. So that's the first type that we can have. The second type that we can have, okay, for these for these inequalities is what we call as a quadratic. Okay, so a quadratic inequality. So this simply means that inequality just has a quadratic equation. Okay, so for example, it can be x squared plus 5x minus 2 is less than 0. Okay, so we see that in this inequality, we have a quadratic like that. Then we're going to say that is a quadratic inequality. All right, and then the next type is, I should say, polynomial type. Polynomial. Okay, those are polynomial type. So this one is for those inequalities that have x power 3 or more. Okay, so for example, if I have x to the power 3 plus 2x, okay, squared minus x minus 1 is greater than or equal to 0. You can see that the highest power here on x is 3. So we call this as a polynomial inequality. Okay, we call it as a polynomial inequality. And then the fourth one is what we call as the rational, or the word that is most familiar to you guys, the fraction inequality. Okay, so just say the rational or the fraction type. So this simply means an inequality with a fraction. That's what it means. So for example, I can have x minus 3 divided by, let's say 3x plus 1, and this will be less than or equal to 24. Okay, so that is a rational or a fractional type of what? Inequality. It is in form of a fraction like that, as you can clearly see. Okay, so these are the four types of inequalities that we have. And then all of these types, or all of these four types of inequality, they can be turned into what we call as a modulus inequality. Okay, so we're going to put the modulus type here as the fifth one, but the fifth one, okay, can actually work or can be applied on any of these four that you can see here. So I'll say modulus type. So modulus type simply means you've just added the absolute values or the bars to whatever inequality that you have. So if, for example, I get this, then I say bars 3x plus 5 bars less than 7, then this one here becomes a linear modulus inequality. Okay? Becomes a linear modulus inequality. If I put the modulus here, this will be a quadratic modulus inequality. Okay? If I put the bars here, it will be a polynomial modulus type inequality. If I put the bars there, it will be a rational modulus type inequality. Okay, so the rational one works on all these four types of what? Inequalities. Okay, so of these five types that I've written down here, okay, of these five types of inequalities that I've written down here, okay, you can only solve using the direct method, you can only solve the linear one, okay? And then the quadratic one, the polynomial one, all the way to the modulus type, you always need what we call as a sign graph in order to solve those inequalities, okay? But for the linear one, we can just go direct. We find the range of values for x, okay? But for the quadratic one, for the polynomial one, for the rational, for the modulus, we are always, okay, going to use what? A sign graph. Okay, so what is a sign graph? Okay, a sign graph is just a table, okay, that has critical values or values at the boundary, and then we are going to be using it to find in which region is this inequality valid. Because remember, the inequalities, they don't give you one answer to a specific question, right? They give you a range of values in which that equation that you've been given is defined. Okay, so for all these 1, 2, 3, 4, we're going to be using a sign graph, okay? But for the linear type, we're just going to solve direct. So the linear type is what you're doing in grade 7. Yeah, what you're doing in grade 7, that's the linear type, or grade 9. All right, so I'll start with the linear type, go to the quadratic, and then move like that. All right, so let's start with the linear type, which is the easiest. Okay, so if you have any question, please ask. So I'll say, for example, solve this inequality. 3x minus 7 is less than or equal to 2x and then plus 1. Okay, so here we're just going to say like terms together. So it will be 3x remains there. This comes the other side, so it is minus 2x is less than or equal to 1. This minus 7 goes to the other side, so it becomes plus 7. Okay, so this will just be x is less than or equal to what? To 8. And this is the answer here. Okay, so for the inequalities, we're going to be finding a range of values to be our answer. Okay, so this answer now, you can put it on the number line and you can also put it in interval notation. So x is less than or equal to 8. In interval notation, this is simply saying x can take any value from minus infinity all the way to 8, and then the 8 is included there because here there's less than or equal to sign. Okay, and then if you are to plot it on the number line, it will be something like here I have minus infinity, somewhere I have 0 there. I can put just a negative number here for show off. And then there's 8 and then positive infinity there. So this simply means this inequality starts here, or the range of values of x starts here. So I've put a shaded circle here because there's a square bracket like that. If there was a curved one like this, I would have put a circle here like this, which is not shaded. Okay. So, and then we move to the left like this, all the way to infinity. So all these values here, they can work when you get them and put them into what? Into this inequality there. So that's a linear one. Okay, very easy to solve. Okay, so let me give another example. So another example of a linear type is this one. So I have 2x minus 5, okay, less than or equal to, let's say 7. So this will just be 2x less than or equal to, greater than or equal to 7. This one goes to the other side, so it's plus 7. So this is 2x is greater than or equal to what? 12. Then I divide by 2. I divide by 2. X is greater than or equals to what? To 6. Okay, so this is the value or the answer. I can represent this as a set interval notation. So I'm starting at 6 and then going to positive infinity. Because here they're saying x is equals to 6, or all the numbers that are greater than 6. So when you put it in interval notation to be 6, all the way to positive what? Infinity, like this. Okay, and then when you try to show it on the number line, it will just be, if this is my 0, this is 6, that is positive infinity. I'll say I'm starting at 6 here. Okay, and then I'm going to the right like this. So I'll shade all this part here. That is my answer there on the number line. All right, so any questions there? Okay, any questions on this is what? This is the linear type. Okay, so the linear type, I'm sure we don't have any questions, right? Because it's so simple. And then now let's move to the quadratic type. Okay, let's move to the quadratic type. So the quadratic type, we said we're going to be solving it using a what? A sign graph. Okay, but later on, I'll also show you some tricks in which you can avoid the sign graph, but still come up with the same answer. So let's solve this quadratic equation here. Okay, let's solve this quadratic equation here. So let's say, okay, where is the what? The quadratic equation that I want to use. Okay, I think I have it on the next page. All right, so this is the quadratic equation that I want to use. Okay, so for the quadratic, we said we are going to use the what? The sign graph. So we have 3x squared, okay, plus 5x minus 3 less than or equal to 2x squared plus 7x. So the first thing is to say put like terms together. Okay, so this will be 3x squared. This guy here comes to the other side, so it's minus 2x squared. And then I have plus 5x. Okay, this other guy comes to the other side, so it's minus 7x. And then I have minus 3. And this is less than or equal to what? To 0. Okay, so that is what I have there. Okay, that is what I have there. So let's combine now. So 3x squared minus 2x squared, it gives me x squared. And then 5x minus 7x gives me minus 2x. Okay, and then I remain with the minus 3 is less than what? 0. Okay, so this is the equation that I've come up with, right? So when you reach here, the point where you've put your equation in a standard quadratic form, okay, remember the standard quadratic form is this guy here. Okay, so once you've put it in standard form like that, then you just have to solve the quadratic equation in the normal way you would solve the quadratic equations, okay? So how do we solve the quadratic equation? We said we can use completing the square, we can use the formula method, and we can use the factor method. So here we're going to use the factor method, okay? So I'm going to say factor, product factor sum there. So the product is the coefficient of x squared multiplied by the constant. So that will give me a product of minus 3. The factors I will skip it, and then the sum is the coefficient of x, which is -2. So this is -2. So now what will be the factors? So what two numbers can we multiply to get -3? But when we add them, we get -2. What two numbers? Anyone to try? What two numbers can we multiply? We get -3, but when we add them, we get -2. Anyone to try? Come on, guys. Try. Okay, so the factors here will be +1 and -3. So when I multiply them, you see I get -3. When I add them, I get -2. Okay, so it means this -2x here, I'm going to write it in terms of the factors. So it will be, okay, x squared, and then I'll say minus this 2x, I'm writing it in terms of the factors. So I'll say plus x, and then -3x, okay, and then -3 less than or equal to what? To 0. So you see that this part here is the one that gives me 2x there. So from there, I'm just going to group this like that. Okay, so what is common here is x. Then what remains is x plus 1. What is common here, you can clearly see is -3. So -3, I factorize it. I remain with x plus 1. And then this will be less than or equal to what? To 0. Okay, so x plus 1 is common, so I write it once. And then this guy here, which is outside, x and -3, I combine them like that. Then less than or equal to 0. Okay, so this is what I have there. Okay, so when you reach there now, don't ever make a mistake of doing what I'm going to do here. So you say x plus 1 is less than or equal to 0, and then x is less than or equal to -1, and then x minus 3 is less than or equal to 0, then x is less than or equals to 3. And then you say, hence solved. No, okay? It does not go like that. These are inequalities. They are not equations, okay? If there was an equal sign, then we would go by this. But because there's inequality here, we can't go by this method. This is wrong, okay? So what do you do instead? Okay, you draw a sign graph. So how do you draw a sign graph? You first find what we call as the critical points or the critical values. So the critical values, you get them by equating this factor to 0, solving for x, this factor to 0, solving for x. So I'll say, let me get my critical points or my critical values. Okay, so I'll just say critical v's. So that would be x plus 1, okay, is equals to 0. This simply means x is equals to -1. And then x minus 3 is equals to 0. This simply means x is equals to what? To 3. So these are my critical values there. Okay, these are my critical values. So now remember this equation that you have here. So I'll keep it here. Okay, and then from there, once you have your critical values, you're just going to arrange them on a sign graph, like you're arranging the numbers on a number line. So you arrange them in order. Okay, so what I mean is that the smallest between this -3, -1 and 3 is the 1, right? So I'll say -1 there comes first, and then the 3 somewhere. Okay, and then from here, I'm going to draw a sign graph. So a sign graph is just a table. So it will be in this form. So this -1 here cuts the table into a section, and the -3 also does the same. And then there I have, in this first box here, I'm going to have my factors. Okay, so here I only have 2 factors. So I draw 3 rows. Okay, so 2 rows for each of the factors, and then the other one is what will be calling as the overall row. Okay, or you can simply write this same thing there. Okay, so the first factor that I have is x plus 1. The second one is x minus 3. Okay, so now here is -1, here is 3. Okay, so before I reach -1, I'm going to pick any number that is between -infinity and -1. Okay, so here we can pick -2. Let me be writing it with a different color. So I can pick -2 here as my testing value. So any number, as long as it's less than -1, you can pick it there. If you want, pick -200, okay, -2 million, whatever number you can pick there. But I'll just pick the smallest one so that my calculations are easy. And then between -1 and 3, you pick a number as well. So here I'm going to pick 0. Okay, so if 0 is an option anywhere, always pick 0. Okay, but you can literally pick any number between -1 and 3. If you want, you can pick 2.5. There's no problem. And then after 3, I'm just going to pick 4. Okay, so just make sure you pick simple numbers. And then once you have these numbers now, you start testing them. So if you take this -2 and put it here, what are you going to get? Okay, it will be -2 plus 1, which will just give me what? -1. So if your answer is negative, you just come here under in this first box, you write minus. Okay, don't write -1, just write the sign of your answer. That's all. Okay, then now we get 0, we put it there. It will be 0 plus 1. This will just be +1. So the answer that I get there is positive. So I put positive. Okay, this is what we call as the sign table. No wonder we say sign table, because it will just have the sign. Then if I get 4, I put it where the x is. It will be 4 plus 1, which is equals to 5, and 5 is positive. So that will be positive. Okay, then now we go to the second factor. If I get -2, I put it here. That will be -2 minus 3, which is equals to -5. So that will be negative. If I put 0 there, it will be 0 minus 3, which is equals to -3. And this is what? Negative. So that will be negative. If I put 4 there, it will be 4 minus 3, which is equals to what? 1. And 1 is positive. So I'll put positive there. Okay, so now I'm done with my two factors. It's time to find the overall. So to find the overall, you're just going to be multiplying. So negative multiplied by negative, I get positive. Positive and negative, I get negative. Positive and positive, I get positive. Okay, done. So now once you complete your sign graph, okay, you have to go back now and check the sign that you had in your inequality. Okay, when it was in terms of the factors. So when it was in terms of the factors, the sign that I had there was less than or equal to. Okay, was less than or equal to. So if this whole thing here is less than 0, then it means whatever is here should be what? Should be negative, because it's less than 0. Okay, so now on your sign graph here, on the overall row here, you're going to concentrate on the part that gives you a negative sign. Okay, you're going to concentrate on the part that gives you a negative sign. So that part is between this -1 and 3. It's the one that gives me this negative in the overall row. Okay, so this simply means that your answer, okay, to this inequality that you had here, your answer is simply -1 to 3. That's your answer there. Okay, so now why am I putting square brackets here? You have to know the reason. The reason is because here in the inequality, I have less than or equal to. So this or equal to, it means that the boundaries there should be included. No wonder I'm putting a square bracket there. If there it was just less than, then our answer would be curved bracket -1 and then 3 curved bracket like that. All right, so our answer is this one. And then you can go on and even represent it on the what? On the number line. So on the number line, it's just -1 and 3 somewhere. Shade on 3, shade on -1, and then draw a line and then shade there like that. Okay, so that would be the answer there. So any questions there on the quadratic inequality, on how to solve it? Okay, so if there are no questions, we move to the next one. So the next one is supposed to be the polynomial type. So now let's look at the polynomial type. Okay, so the polynomial, it simply means the highest power on x is 3 or more. Okay, so let's say, for example, we are given this question to solve. How are we going to handle it? So they say solve x to the power 3 minus 2x squared minus x, and then plus 2 is greater than 0. Okay, so you can see the highest power on x is greater than 2. So this is a polynomial type. Okay, so what we need to do is just to factorize this polynomial, okay, into its factors. So to factorize this polynomial here, we're going to use the rational root test. Okay, so first of all, we need to know the possible roots to this equation. So by roots, I mean the possible answers to this here polynomial. So how do you get the possible answers? You focus on the coefficient of the variable with the highest power. In this case, it is this x power 3. So the coefficient there is 1. And then the constant is 2. So you multiply that, okay? Or you just simply say plus or minus 1, okay? And then plus or minus 2. So the possible roots will be all the numbers that can divide these numbers. Okay, so positive 1 will be a possible root, minus 1 will be a possible root, minus 2 will be a possible root, positive 2 will be a possible root. Okay, so we can use that to factorize. But if you want, you can simply use synthetic division, okay, and the like. But I'm going to use this very simple method here. So I'm going to try to see if 1 is a root, or if minus 1 is a root, or if minus 2 is a root, or if 2 is a root. So if this is a root, then when I replace it into this equation, I should get a 0. Okay, so I'm just going to say let f of x be equals to x to the power 3 minus x minus 2x squared minus x plus 2. Okay, so here I'll say let my x be 1. So my f of 1, what is it? If this gives me 0, okay, then this guy here becomes a factor. I'll just take the 1 the other side. So it will be 1 to the power 3 minus 2, 1 squared minus 1 plus 2. So this will be equals to 1 minus 2 minus 1 plus 2. And we see that this is equals to what? To 0. So it means this guy here is a factor. So how do I write it as a factor? I'm going to write it as x. This one goes to the other side, so that is minus 1 like this. So x minus 1 is a factor. So we found the first factor. Okay, let's try to put in minus 1. So if x is equals to minus 1, what will be f of minus 1? So this will be equals to minus 1 to the power 3 minus 2 minus 1 squared minus 1 plus 2. So minus 1 to the power 3, that is simply minus 1. And then inside here, minus 1 squared, that's positive 1, multiplied by the 2, I get minus 2. Negative and negative, they give me plus 1, and then I have plus 2. So this also gives me a 0. So it means this guy here is a factor, so I just take the negative 1 the other side. So that would be x plus 1. So x plus 1 is also a what? A factor. Okay, and then we try one more. Okay, so let's try x is equals to 2. So f of x is equals to 2 to the power 3 minus 2, and then 2 to the power 2 minus 2 plus 2. 2 to the power 3, that is 8. And then this one here will be minus 2 multiplied by 4, that will be minus 8. And then I have minus 2 plus 2. So this here is simply 0. Okay, so meaning that this guy here is actually what? A factor. So it will be x minus 2. So that will be x minus what? 2. All right, so those are the factors there. If you want, you can test this one here because this is a cubic function. The highest power is 3. So we can only have 3 factors, okay? So testing this is useless. But if you test this, you're going to see that what you're going to get is not a 0. So simply meaning that those are the 3 factors that will make up this polynomial here. So I can write that polynomial now in terms of what? In terms of its factors. Okay, so I'm just going to say this polynomial here is the same as x minus 1, x plus 1, and then x minus 2 is greater than what? 0. Okay, once I have expressed this polynomial in factors, I just have now to find the critical values, and then I draw a sign graph. Okay, so my first critical value will just be when I equate this to 0, which is x is equals to 1. This is x is equals to minus 1, that is equals to x is equals to 2. So I arrange this, okay, in order. So I start the minus 1, and then 1, and then 2. Okay, and then I just draw the graph there, the sine graph like this. Okay, so these ones here are going to be the what? The factors. Okay, so now I'm testing any number for this part here, any number that is less than minus 1. So there, I'm just going to test minus 2. Then any number between minus 1, okay, and positive 1, I'm going to test 0. Any number between 1 and 2, I'm going to test 1.5. Any number after 2, I'm going to test what? 3. Okay, so now let's write the factors that we have here because we have 3 of them. Okay, and then we have the over there. Let's write properly. Okay, so the first factor is x minus 1. Then I have x plus 1. Then I have x minus 2. Okay, and then here it will be the overall. So let's test. Okay, so this one, if I put minus 2 where the x is, I'll get minus 3 here. So minus 3 is a negative number. If I put 0 there, I'll get minus 1, negative number. If I put 1.5, I'll get positive 0.5 because it will be 1.5 minus 1, positive 0.5. So this is positive. If I put 3 there, again, I get positive. Okay, if I put minus 2 here, to be minus 2 plus 1, minus 1, so I get minus. If I put 0 there, I get positive. If I put positive there, I get positive. Even there, I put a positive number, positive. Okay, what about if I put minus 2 there? It will be minus 4, so that will be negative. If I put 0 there, okay, it will be, what will it be? Okay, if I put a 0 there, it will still be minus. And then if I put 1.5 there, to be 1.5 minus 2, it will give me minus 0.5. So that is still a minus, okay? And then if I put 3 there, that will be plus. Okay, then I get the overall. So I say negative multiplied by negative, positive. Positive multiplied by negative, negative. Negative multiplied by positive, negative. Negative and negative, positive. Positive and positive, positive. Positive and negative, negative. Positive, positive, positive. This will just be positive. Okay. So we are interested in which regions. Okay. So you check the sign that you have there. Okay. The sign that I have there is greater than. So this whole thing here should be greater than 0. So I'm just interested in the positive what? Regions. Okay. So the positive region is between here, okay, and there. So between here, that's between minus 1 and positive 1. Then I'll say union. The other one is 2, okay, all the way to positive what? Infinity. Okay, so that will be the answer for this polynomial type of what? Of inequality. Okay, so we said the answer there is simply minus 1, 1, and then union 2, all the way to positive infinity like that. So this is the answer there. Okay, so that's how we deal with the polynomial type. And then from there, we can move on to the fraction type. Okay, unless you guys have questions. All right, so let's move on to the fraction type. So the fraction type will be in this form. So for example, if they give me solve 2x minus 3 divided by 4 plus, x plus 4, and then they say greater than 1. Okay, so how can I solve that? Okay, it's a fractional type. How can I solve it? All right, so it's very easy. What you need to do here is always make sure that whatever you have here is 0. Okay, so when it comes to inequality, never cross multiply. So don't do this and then you say cross multiply. No, that would be totally wrong. So whenever you're dealing with inequalities, never cross multiply. Instead, I'm going to bring this guy to the other side, okay, and then combine with what I have here, making sure that on your right, you always have 0. So this will be 2x minus 3 divided by x plus 4 minus 1 greater than what? 0. So divide by 1 there. Okay, and then I say the common denominator there will be 1 multiplied by x plus 4. X plus 4 there, okay, it will just be 1 multiplied by that. I get 2x minus 3. And then this here will be minus 1. Then 1 into that, it will be x plus 4, like that. Okay, and then this here will just be greater than what? 0. So on top, we have 2x minus 3 minus x, and then minus 4, divided by x plus 4 greater than what? 0. So now, when I combine what I have on top, okay, what do I get? So that would be 2x minus x, I get x, and then minus 3 minus 4, I get minus 7, divided by x plus 4 is less than, greater than 0. Okay, and then from there, we're just going to say, let's find the critical points. So now here, when you're dealing with a fraction, always be careful with the what? With the denominator, because we know that the denominator can never be 0. So when finding the critical points here, I'm just going to say x minus 7 is equals to 0. So x is equals to 7. So this is my first critical point. But for this critical point from the denominator, you're going to say x plus 4 should never be equals to 0, because it's in the denominator. Then this will just be x should not be equals to minus 4. So minus 4 and 7 are our critical values. Okay, so now I'm just going to draw a table. So that will be minus 4 and then 7 somewhere. And then, okay, so this is what we have here. Okay, so we have x minus 7, then x plus 4, and then the overall. Okay, so let's just do the testing now. So these are the factors here. So just get any numbers in those desired regions. So any number less than minus 4, I'll get minus 5. Any number between minus 4 and 7, I'll get 0. Any number after 7, I'll simply get 8. Okay, so let's test minus 5 there. So if I put minus 5 there, to be minus 5 minus 5, which would be minus 12, so this would be negative. If I put 0 there, it will be minus 7, that would be negative. If I put 8, it will be positive 1, because it will be 8 minus 7, positive 1, so I put positive. If I put minus 5 there, to be minus 5 plus 4, minus 1, so this will be minus. If I put 0 there, it will be positive. If I put positive 8 there, again, to be positive. So it means the overall will be negative and negative gives me a positive. Negative and positive gives me a negative. Positive and positive gives me a positive. Okay, and then now you check the sign that you have there. Okay, so the sign there says greater than. So I'm interested in the positive regions. So my answers are going to be a union of this region and this region. So I'm going to say my answer is equals to, okay, I have minus infinity all the way to minus 4. Okay, the 4 is not included, and then union 7 all the way to what? To positive infinity. Okay, so that would be my answer there. Okay, that would be my answer there. Okay, so that's how you handle the fraction type. Okay, that's how you handle the fraction type. So let's move forward now. Maybe I should show you the website for those who do not know how to access it. Okay, so if you want to go to the website, you just go to Chrome and then you type in discretelearning.com and then you click open. So it's going to open here, you can see. So the courses that we offer are there. So depending on whatever course you've registered for. So if it's math, you go and open math. And then you go in this folder written general mathematics. Okay, in the general mathematics folder, you're going to find topic lessons here, summarize handwritten notes, tutorial sheet and assignment solutions, past quiz test, and exam paper solutions. So if you want to learn maybe a topic in detail, you can go in this folder here. Okay, you find the lessons there. Then if you want solutions to the tutorial sheets, you go in the folder for the tutorial sheets. So let's try to open the folder for the tutorial sheets. So here it will depend with the university where you are. So you guys are from Mukua, right? So you go in the Mukua University folder here. And then you go to the 2025-2026 intake. You're going to find the tutorial sheet. So full videos, tutorial sheet 1, tutorial sheet 2. So if I open this same tutorial sheet 2, you are going to see. Okay, so you can see question 1, all of them, I've arranged them very in a very ordered way, and I'm naming them of what you're going to find in that video. So for example, question 11, we are solving modulus equations. You're going to find. Okay, so what we are doing here, that was question 12 in the tutorial sheet. So how to solve various inequalities. You can watch this video at your own time and learn how to complete a square. All these videos are there, all the way to 25, where you are decomposing partial fractions. Okay, binary operations, the videos are there. So make sure, guys, at your own free time, don't feel lazy. Okay, at your own free time, just go to the website or on the mobile app. In fact, the mobile app is the best because you'll be able to download the videos and watch them even offline. So you pass through these videos, okay? Because whatever I'll be teaching during the live classes, I've already said it in the recorded classes. All right, so thank you so much for watching. For those who will be watching this video on YouTube, if you'd like to register with us, okay, you can simply check the video description, okay, below here. You're going to find the link to our website, the link to our mobile app, and the video registration guide that's going to guide you on how you can register with us. So now, having gone through that, okay, we can now talk about the modulus ones. Okay, we can now talk about the modulus ones. So the modulus ones are in 3 types. Okay, so modulus. And these ones are the ones that they like bringing in the exam. Okay, so the modulus inequalities are in 3 types. So I'll say type 1, type 2, and then type 3. Okay, so type 1, it has a single modulus. So for example, you have a function f of x, okay, which is in modulus like that. And then you have less than here, or it can be greater than, okay, or it can be less than or equal to, or it can actually be greater than or equal to. And then here we're just going to have a value. So let's say a value b. Okay, so it can be whatever is in the modulus here is less than b, or whatever is in the modulus here is greater than b, or whatever is in the modulus is less than or equal to b, just like that. So this is the first type of modulus equation. Okay, and then second type is a double modulus inequality. Okay, it's a double modulus inequality. So this one here has double modulus. On the left and the right, it will have a modulus. So it will be a function f of x like this. Okay, and then on the middle here, you can have less than, you can have greater than, less than or equal to, greater than or equal to. And then on the other side again, I have a modulus equation like this. Okay, so how do we handle such with double modulus? And then the third one is the one with no solutions. Okay, so when you just see it, the answer is just no solution. Okay, so those are the 3 types of inequalities that we have: double modulus, single modulus, and the type that gives you no solution. So the no solution type. All right, so I'll start with the no solution type. Okay, I'll start with the no solution type. So we know that whatever comes out from the modulus is a positive value, right? Okay, so for example, if I would write modulus of x minus 4, okay, is less than minus 3. This equation here, once it comes maybe in a test, okay? Don't even bother trying to solve it. No, it doesn't make any mathematical sense because whatever is in the modulus here is going to be positive, and the positive number can never be less than a what? Than a negative number there, okay? So once you see such, where you have modulus less than a negative number, just say this equation has no solution, okay? There's no solution. All right, so that's about those ones with no solution. Or it can also be, they can try to decorate it to just confuse you. They can say maybe 5x minus 9 divided by 2 minus 5x, and then they say modulus less than minus 1. Okay, as long as the modulus, okay, as long as they're saying a modulus is less than a negative number, then this does not exist. So you're going to say no solution. Okay, it has no solution. Because a negative, I mean, a positive number can never be less than the what? The negative number. All right, so that's the first step with the no solution. So you've seen it. I've given an example. And then the single modulus one, okay, we can talk about the single modulus one. So we use an example. So uh, before I even talk about, I mean, before I give an example, okay, let me give the general rule that you use. So if, for example, let's modulus of f of x, okay, and then they say less than, okay, modulus of f of x and then less than b, okay, how you should handle this should always be in this form. We know that modulus here hides the negative, right? So these bars here, it's the same I write plus or minus, okay, f of x in brackets now, and then less than what? B. Okay, so this modulus here simply means plus or minus the f of x that you have. And then from here, I'm going to multiply first this f of x with the positive. So I'm just going to get f of x is less than what? B. If I multiply with the positive. If I multiply with the negative, I'm going to get minus f of x is less than what? B. And then the function should not have a negative, so I'll divide by minus 1, divide by minus 1. So here the negative goes, okay? But because I've divided by the negative, the inequality sign changes the direction. So this was less than, if I divide by a negative, it becomes greater than what? Minus b. Okay, so in short, whenever you have a negative, I mean, whenever you have modulus less than a single value like that, okay, you should always write your equation in this form like that. Okay, so you can see this part here is this part where I'm saying f of x is greater than minus b. This is f of x is greater than minus b. Okay, and then the other part that we get when you have a positive is this part here. Okay, so that's how you should always treat a less than or equal to. It will be in the same fashion there. So this simply means that now to find the answer to this equation, okay, you're first going to solve this part, okay, and then you solve that part. Okay, so I'm just going to say minus b less than f of x here. So you solve this part, and then the other part is f of x less than b. You solve this part. Okay, so from this part, you're going to get an answer. Even from this part, you're also going to get an answer. Okay, so if you have less than there or less than or equal to, the answer that you get there and the answer that you get here, you're going to intersect them. And that will be your what? Your final answer. Okay, so you divide it into two, solve this part, and then those answers that you're going to get, intersect them. The intersection is the final answer. Okay. So that's what we've said there. If it is a modulus and a less than, okay? And then if it is a modulus and greater than, okay? So f of x here, modulus, and then maybe say greater than or equal to b. Okay, so it will be the same. This one here is the same plus or minus f of x, and then greater than b. Okay, so this simply means when I multiply by plus, I will have f of x greater than or equal to what? To b. And then multiply by the negative minus f of x greater than or equals to what? To b. And then what you're going to do is that solve this, okay? Here you're going to get an answer. Even there, you're going to get an answer as well, okay? So the answer that you're going to get here, if you had greater than there or greater than or equal to, you're going to unionize them. And that will be your final answer. So always remember these rules, okay? Because without these rules, then you won't get the correct answer. Okay, you will just be doing things randomly without even understanding. Okay, so if you have less than or equal to, the answers that you get from the two parts of the equation intersect them. If you have union, the answers that if you have greater than or equal to, the answers that you get from the two parts unionize them. Okay, so that's the rule. So now let's take a look at one example where we have a modulus equation. Okay. Okay, so I'll give an example of a linear, and then I'll also give an example of a fraction one, because those are the ones that are common. So, for example, I have modulus of 2x minus 5, and then greater than or equal to 7. How do we solve this? So we said we're going to say this modulus here is the same as plus or minus, and then I have 2x minus 5 greater than or equal to 7. So now I separate. When I multiply by the negative, the positive, that will be 2x minus 5 greater than or equal to what? 7. When I multiply by the negative, it will be minus 2x minus 5 greater than or equal to 7. So let's solve this. Okay, so this will be 2x greater than or equal to 7 plus 5. And then to be 2x greater than or equal to 12, divide by 2, divide by 2, x here is greater than or equal to what? To 6. Okay, so this is what I get from my first part. From the second part, let's multiply by the negative, or in short, we can just divide by the negative. So if I divide by the negative, okay, so just divide by -1, even here by -1. So I'll get 2x minus 5. Since I've divided by the negative, the sign of this guy has to change the direction. So it will now become less than or equal to -7. And then 2x will be less than or equal to, this guy goes to the other side, so that is -7 plus 5. So 2x less than or equal to -2, divide by 2, divide by 2, x is less than or equal to what? -1. Okay, so this is the answer that I get from the second part. This was the answer that I got from the first part. So what do I do with them? So since he had a union, at a union now, since they had a greater than, okay, or equal to, we said we are going to be unionizing the answers that we get. So how do you unionize? You put these answers on the number line. So -1 is somewhere there, 6 is somewhere there. Okay, so I'm going to say for 6, I'm starting at 6 here, and then going to positive infinity like that. And then for -1, I'm starting at -1 and then going to minus infinity like that. So the answer is in two parts. There's this guy and then there's that guy. Okay. So the final answer, since we had greater than or equal to there, or even if you had greater than, you just have to unionize the two. So the first part is minus infinity all the way to -1. Okay. And then you say union 6 all the way to what? To positive infinity. So this one here is your final answer. Okay, so any questions there, guys? Any questions that you have there? Okay, you don't have any questions? All right. Okay, so that's how we can handle a modulus in a linear equation, because this is a linear here, and then we just put a modulus. Okay, so divide it into 2, solve the other part, solve the other part, and then if you had greater than or equal to, unionize the final answer. Okay, if you had less than or equal to, intersect the answers. That's all. All right, so now let's move and take a look at some fraction inequalities that have a modulus. Okay, let's move and take a look at some fractions inequalities that have a modulus. So we start with the first one there. Okay, so this one here. So I'll write it here. So I have x plus 1 divided by x minus 2 modulus. Okay, and then less than or equal to what? To 3. So what do you think we should do? Okay, so we said this guy, the modulus is the same as plus or minus what? Whatever is there. So x plus 1 and then x minus 2. Less than or equal to 3. All right, so multiply by the positive. What are we going to get? Okay, so let me hide this to save some space. Okay, I will just put it at the corner like that. Okay, so if I multiply by the positive, I'm going to have x plus 1 divided by x minus 2 less than or equal to what? 2, 3. If I multiply by the negative, okay, If I multiply by the negative, it will be minus, and then x plus 1 over x minus 2 less than or equal to 3. So here I'm just going to divide both sides by minus 1. Even the other side I divide by minus 1. So what I'm going to get, it will be x plus 1 over x minus 2. And then since I'm dividing by a negative, this guy here changes the direction. So now it will be greater than or equal to minus 3. Okay, so the two parts of the inequality that I have is this one, 1, and then this one, 2. Okay, so we're going to solve those, and then their final answers, we're just going to what? To intersect them, because here we had a less than um, or equal to. Okay, so let's do that now. Okay, so we start with the first one there. So the first one is x plus 1 divided by x minus 2. So I can see a 3 there. Okay, so some of you might be tempted to just equate this to 0, equate this to 0. You find your critical values and then you do whatever you want. But no, you have to make sure that on the other side of the inequality there's always 0. So if there's no 0 there, you bring whatever is there to the left. Okay. Another rule is that never cross multiply when you're dealing with inequalities. So some of you might do 3 over 1 and then you say cross multiply. Then you get 3 multiplied by x minus 2. Then you say less than x plus 1. No. Okay, this is not correct. You never cross multiply when you're dealing with what? Inequalities. Instead, bring everything to the same side so that the other side just remains with the 0. So I'll bring this to the other side. So that will be minus 3 over 1, and then less than or equal to what? To 3. And then I'm going to add these or combine them. So that will be x minus 3 with a 1 less than or equal to 3. So x minus 2 into this, it will cancel out the x minus 2, so it will just be 1. Then multiply by x plus 1, that will be x plus 1. Okay, and then I'll say minus 3 there, multiplied by 1 into this, it will be x minus 2. So I'll write x minus 2 there. Okay, so meaning that what we get on top, it will be x plus 1 minus 3x plus 6 divided by x minus 2 less than or equal to, why did I write 3 here? You guys are not speaking. You're not correcting me. We brought the 3 the other side, so meaning here we remained with the 0 KD. Okay, so meaning on top there it is x minus the 3x, that will be minus 2x, and then 1 plus the 6 there. It's going to be what? 1 plus 1 plus the 6 there. It's going to be okay. So what do we get there? Okay. So that would be 1. Okay. So we get 7, right? So that will be plus 7 divided by x minus 2 less than or equal to 0. So now we have a factor on top there, a factor down, and then we are saying less than or equal to 0. This is when we can find the what? The critical points. So the first critical point, I get the numerator there, minus 2x plus 7. I equate it to 0, and this is just going to give me minus 2x is equals to minus 7. So x is equals to minus 7 over minus 2, which is just 7 over what? 2. So this is my first critical what? Point. Okay, but now I want you to take notice of what I'm going to do to the of what I'm going to do to the what? To the factor in the denominator. Okay, maybe I forgot to mention it on the other one. So for the factor in the denominator here, the denominator can never be 0. Yeah, I think I forgot to mention it on the other one that we did. So the denominator can never be 0. So when you want to get the critical point for this guy here, you always say x minus 2 is not equals to 0. Okay, so I didn't mention it on the other one. So make sure you correct the other one. I've just remembered it now. So this here, the x minus 2 can never be 0. But because when it is 0 here, it means that everything here becomes undefined. Okay, so we're going to say here, the other critical value is just simply what? The 2. So I have two critical values, 7 over 2 and 2. Okay, That's what I have. Okay, 7 over 2 and then 2. So 7 over 2 is the same as 3.5 if you try it on your calculator. Okay, and then once we have those critical values now, we can write this on the sign table. Okay, so let's put the sign table. So 2 and then 3.5 somewhere. And then we divide this into a table. Okay, so this one here will be x plus 1. No. What was the factor that I got? Okay, that was minus 2x plus 7. And then the one which was down was x minus 2. Okay, and then I have the over. So here I'm just solving the first part of the inequality. We haven't yet come to this. So what numbers can I use to try out in here? Okay, so number before 2, I'll use 0. Between 2 and 3.5, I'll use 3. And then after 3.5, I'm just going to use 4. So now let's put them into these factors. So if I put 0 there, it will just be positive there. Okay, if I put 3 there, it will be minus 2 multiplied by 3 minus 6 plus 7 positive 1. So this will be plus again. If I put 4 there, to be minus 2 multiplied by 4, that will be minus 8 plus 7, I get minus 1. So that will be minus. Okay, and then I test this other factor here. So this is, if I put 0 there, it will just be minus 2. So that is negative. If I put 3, it will be positive. If I put 4, it will be positive. So it means the overall that we get from this part to be negative. Okay, to be negative, plus, and then negative. Okay, so now which part are we interested in? Okay, we're interested in the negative part there because here we have a what? Less than or equal to. Okay, so remember that equation that we found when we brought the 3 the other side, it was minus 2x plus 7 over x minus 2 less than or equal to 0. So this whole thing is less than or equal to 0. So meaning that we are focusing on the negative part there. Okay, so let's get the two negative answers. Okay, so this one here, I'm going to say this one here is just between minus infinity and 2. So that is minus infinity and 2. And this 2 here, will it be included or not be included? Okay, here we strictly said x can never be 2. So the 2 will not be included. And then I say the other part there is union. It starts at 3.5 and then it goes to positive infinity. Okay, so that's what we have there. So any questions there? Okay, if there are no questions, this here is the first answer that we get for the first inequality. Okay, so let's write those answers somewhere down here. So the first answers that we've gotten are these. Okay, when we solved the first part. So now we need to solve the second part, which is what? This guy here. Okay, so for the second part, it will be x plus 1 divided by x minus 2. Then I bring the minus 3 the other side, so it will be plus 3. Okay, and that will be greater than or equal to 0. Divide by 1. Okay, so x minus 2 multiplied by 1, that's a common denominator. If I divide this into that, I'll just remain with x plus 2. 1 into there, it will be plus 3 multiplied by x minus 2 greater than or equals to 0. So this will be on top, I have x plus 1 plus 3x. Okay, plus 3x and then minus 6 divided by x minus 2 greater than or equal to 0. Add like terms, so that will be 4x. 1 and minus 6 gives me minus 5, and then x minus 2 greater than or equals to what? To 0. Okay, and then from there now we can find our critical values. So my critical values will be 4x minus 1 is equals to 0 because it's in the numerator. So that will give me x is equals to 5 over 4. Okay, so 5 over 4 in decimal numbers, it's the same as 1.25 like that. All right, and then the other one is x minus 2 and it's in the denominator. So we're going to say x minus 2 is not equal to 0 So meaning x is not equal to what? To 2. So this guy here and this guy are my critical values. Okay, so I'm just going to get those critical values and then place them on the what? On the sine graph. So it will be 1.25 and then I have 2 somewhere. Okay, and then I can divide this into columns and rows. So the overall will be there. Here. Okay, so the overall will be here. And then here, our 4x minus 5, here x minus 2. So let's pick the numbers that we can test. Okay, so here, any number less than this, I can pick 0 for simplicity. Okay, any number between 1.25 and 2. Okay, I can pick 1.5. Any number after 2, I'll just pick 3. And then let's plug in these values into these factors now. So if I put 0 there, I'll just remain the minus 5, so that is negative. If I put 1.5 there, what do you think I'm going to get? Okay, what do you think I'm going to get? So that would be like 4 multiplied by 1.5, okay, and then minus 5. Okay, so 4 multiplied by 1.5 gives you 6. Okay, and then 6 minus 5 gives you a positive, so that would be positive there. All right, and then if I put in 3 there, it will be 4 multiplied by 3, 12. 12 minus 5, that will be a positive 7. So I'll put positive there. And then I go to the other factor. 0 into that, it will be minus 1.5 into here. So that is 1.5 minus 2. So that will give me minus 0.5. So that will be negative. Okay. And then 3 there, it will be positive. So now my overall ones will be negative and negative, positive. Positive and negative, negative. Positive and positive, positive. Okay, so now when I look at this equation here, here are greater than or equal to 0. So I'm interested in the regions which has what? The positive ones. Okay, so the first region here would just be from minus infinity all the way to 1.5. And I mean the 1.25. And the 1.25 is included. Then I'm going to say union. The other part here is starting at 2, but this 2 here is not equal to 2. So I'll put a curve, and then this goes to what? Positive infinity. Okay, so from the second part, I found this is the answer. From the first part, I found this is the answer. Okay, and then now we check the original inequality that we had in the what? In the initial question. Okay, so the original inequality that we had in the initial question is there. It's less than or equal to. So he said if it's less than or equal to, we're just going to what? We're just going to find the intersection. Okay, we're going to find the intersection. So where are these two answers that we found intersecting? So let's draw a number line to help us with that. Okay, so I'll arrange these numbers that I can see here in order. So minus infinity, positive infinity. Okay, and then I can see a 1.25 somewhere. Then I can see a 2, and then I can see a 3.5 somewhere. Okay, so let's plot first of all this guy here. So I'll plot this one here in green. So that is from minus infinity here, okay, all the way to 2. So the 2 is not included, so I'll put an open circle. So it's like that. Okay, and then the other part of this answer is from 3.5 here, I'm going to what? To positive infinity like that. Okay, so that's the first part of the answer. So I can actually shade this part and also shade that part. So that's the first part of the answer. The other part of the answer, I'm going to put it in blue. So now I'm using this guy here. Okay, so that is minus infinity to 1.25. Okay, so minus infinity to 1.25, and the 1.25 is included. So I shade there, and then I go to the minus infinity. On the other part, I'm starting at 2 here, and then I'm going to positive infinity. Okay, so which part here is intersecting the green part and the blue part? So you can see this part here intersects. Okay, it will have both the green and the blue. And this part also intersecting. It will have both the green and the blue. Okay, so that will be our final answer. So final answer, you now write it in terms of an interval. Okay, we're just going to say the part where we have the blue and the green ones, okay, is from minus infinity all the way to 1.25 included. And then union, we're starting at 3.5 here. The 3.5 is included in the green and the blue as well. And then comma, positive infinity. Okay, so that's the final answer there that we what? That we get. All right, so any questions there, guys? Any questions that you have on what we've done? Okay, so that's basically it on the inequalities. Okay, so it's either a linear one will come, or a quadratic one will come, or a polynomial one, which we'll discuss more later on, or a fraction one will come, like the one we are from solving, or to any of these four that I've said, they will add the modulus, and then they'll ask you to solve. As simple as that. Okay, as simple as that. So if you have been following what I was saying, what is the answer to this question here on C? Anyone who can help us? What's the answer to this question on C there? Anyone? What's the answer to that part on C there?
No solution.
Okay, exactly. Okay, so the answer there is no solution. Why is there no, if there no solution there? Because they are saying the modulus is less than a negative number, of which it can never be. Okay, so the other one there, you can try it out. Try it out, solve, and then you send the solutions to my inbox. Then I'll be able to guide you if what you're doing is correct or what you're doing is actually what? Wrong. Okay, so my number is 0779. You can screenshot it. 097 0779 96 40 10. So that is tutor post solutions. Okay, or you can just simply get it from the group. All right, so those are the basics of the inequalities. I hope you've understood and you're able to solve any type of question now. And also, all those questions in the tutorial sheets on the inequalities, I already solved them. So the videos are there. So whatever I was saying here, I was also saying in those videos. Okay, so if you missed or you haven't watched those videos, just go on the website. You are going to find the videos. Okay, they are there in the tutorial sheet folder. I solved all the questions in the tutorial sheet. For tutorial sheet 1, I solved everything. For tutorial sheet 2, I solved again everything. Okay, from sets all the way to partial fractions. All those questions have been solved with full explanations. So just find time to go through, and then you'll be well and good. All right, so maybe I should show you the website for those who do not know how to access it. Okay, so if you want to go to the website, you just go to Chrome and then you type in discretelearning.com and then you click open. So it's going to open here, you can see. So the courses that we offer are there. So depending on whatever course you've registered for. So if it's math, you go and open math. And then you go in this folder written general mathematics. Okay, in the general mathematics folder, you're going to find topic lessons here, summarize handwritten notes, tutorial sheet and assignment solutions, past quiz, test, and exam paper solutions. So if you want to learn maybe a topic in detail, you can go in this folder here. Okay, you find the lessons there. Then if you want solutions to the tutorial sheets, you go in the folder for the tutorial sheets. So let's try to open the folder for the tutorial sheets. So here it will depend with the university where you are. So you guys are from Mukua, right? So you go in the Mukua University folder here. And then you go to the 2025-2026 intake. You're going to find the tutorial sheet. So full videos, tutorial sheet 1, tutorial sheet 2. So if I open this same tutorial sheet 2, you are going to see. Okay, so you can see question one, all of them, I've arranged them very in a very ordered way, and I'm naming them of what you're going to find in that video. So for example, question 11, we are solving modulus equations, you're going to find. Okay, so what we are doing here, that was question 12 in the tutorial sheet. So how to solve various inequalities. You can watch this video at your own time and learn how to complete a square. All these videos are there, all the way to 25, where you are decomposing partial fractions. Okay, binary operations, the videos are there. So make sure, guys, at your own free time, don't feel lazy. Okay, at your own free time, just go to the website or on the mobile app. In fact, the mobile app is the best because you'll be able to download the videos and watch them even offline. So you pass through these videos, okay? Because whatever I'll be teaching during the live classes, I've already said it in the recorded classes. All right, so thank you so much for watching. For those who'll be watching this video on YouTube, if you'd like to register with us, okay, you can simply check the video description, okay, below here. You're going to find the link to our website, the link to our mobile app, and the video registration guide that's going to guide you on how you can register with us. Okay, so if there are no questions, I'll end here. Thank you so much.